Hello friends, I am Ambiga. Welcome to SA Educational Hub, a platform to share knowledge, service providers, Situn and Ambiga. In this Python tutorial, we will learn what is an operator, different types of operators in Python, arithmetic operators, comparison operators, logical operators, assignment operators, bitwise operators, identity operators, and membership operators. Operators in Python. An operator is a symbol that performs certain mathematical or logical manipulation. Operators are used to manipulate variables and data in programs. There are two general classes of operators, binary operators and unary operators. Binary operator. The binary operator uses two operands for the operation. For example, a minus b. Here the minus sign is a binary operator because it uses two operands a and b. Unary operator. An unary operator uses one operand for the operation. For example, minus a. In this example, the minus sign is a unary operator because it uses a single operand a. Python operators can be classified into a number of categories. They are arithmetic operators, comparison operators, logical operators, assignment operators, bitwise operators, identity operators, membership operators. Arithmetic operators. Python provides all the basic arithmetic operators: plus, addition or unary plus, minus, subtraction or unary minus, asterisk, multiplication, slash, division. The output will be in floating point number, percent symbol, modulo division. The expression returns the remainder when a is divided by b. Double asterisk, exponent. It returns first raised to power second, a to the power of b. Double slash, floor division. The floor division operator returns the closest integer value that is less than or equal to a specified value. Example: open any Python IDE or any text editor, type this Python code and run it. 5 is assigned to a, 2 is assigned to b, a plus b is assigned to r, print r, the output will be 7. A minus b is assigned to sub, print sub, the output will be 3. A multiplication b is assigned to mul, print mul, the output will be 10. A division b is assigned to div, print div, the output will be 2.5. The output will be in floating point number. For example, if we divide 4 by 2, the output will be 2.0, not 2 in Python. The output will always be a floating point number in the case of division operator. A floor division b is assigned to fdiv, print fdiv, the output will be 2. The floor division operator returns the closest integer value that is less than or equal to a specified value. So, 5 floor division 2 will produce integer value 2. Similarly, minus 5 floor division 2 will produce the output integer value minus 3. That is the closest integer value that is less than or equal to a specified value. If both the operands are positive, the digits after the decimal points are removed from the result. But if one of the operands is negative, the result is rounded away from 0. A modulo division b is assigned to rem, print rem, the output will be 1. Modulo division operator returns the remainder. A to the power of b is assigned to pw, print pw, the output will be 25. Comparison operators. Comparison operators, also called relational operators, compare two values. The result is a Boolean type, that is, the result is true or false. Python provides 6 comparison operators. Comparison operators are divided into two categories, relational and equality. Comparison operators are all binary operators that accepts two operands and compares them. The result is either true or false. Less than or equal to, greater than or equal to, not equal to. The operators less than or equal to, greater than, and greater than or equal to are relational operators, and equal to and not equals to are equality operators. Example: open any Python IDE or any text editor, type this Python code and run it. Print 5 is greater than 3, the output will be true. Print 5 is less than 3, the output will be false. Print 5 is equal to 3, the output will be false. Print 5 is not equal to 3, the output will be true. Print 5 is greater than or equal to 3, the output will be true. Print 5 is less than or equal to 3, the output will be false. Print 3.0 is equal to 3, the output will be true. Print hello is equal to hello, the output will be true. Print hello is equal to hello, the output will be false. Here H is in uppercase on the right hand side of hello, so they are not equal and the output will be false. Print dog is not equal to cat, the output will be true. Print 4 is equal to string 4, the output will be false. The expression 4 is equal to string 4 evaluates to false because Python considers the integer 4 to be different from the string 4. Equal to evaluates to true when the values on both sides are the same, and not equal to evaluates to true when the two values are different. The equal to and not equal to operators can actually work with any values of any data type. Using comparison operators, we can compare integers to integers, floating point numbers to floating point numbers, as well as integer to floating point numbers. We can even compare strings. The output will be based on the alphabetical order. Logical operators. Logical operators are used to compare Boolean values. Like comparison operators, the result is a Boolean type, that is, the result is true or false. Python provides 3 logical operators: AND, OR, and NOT for combining Boolean values and creating new Boolean values. The AND operator. The AND operator is a binary operator which always takes 2 Boolean values or expressions. The AND operator evaluates an expression to true if both the Boolean values are true. It is false in all other cases. A truth table shows every possible result of a logical operator. The truth table for the AND operator. Expression result. True and true, result is true. True and false, result is false. False and true, result is false. False and false, result is false. The truth table for the AND operator shows that an expression is true if both the Boolean values are true. It is false in all the other cases. The logical operator AND is used when you want to test more than one condition. An example is A is greater than B and A is greater than C. The logical expression is true only if A is greater than B is true and A is greater than C is true. If either or both of them are false, the expression is false. Example: open Python IDE or any text editor, type this Python code and run it. 10 is assigned to A, 3 is assigned to B, 9 is assigned to C. Print A is greater than B and A is greater than C. The output will be true because both the expressions are true. That is, A is greater than B, 10 is greater than 3 is true, and A is greater than C, 10 is greater than 9 is true. So true and true, result is true. In the case of the AND operator, an expression is true if both the Boolean values are true, otherwise it is false. The OR operator. The OR operator is a binary operator which always takes 2 Boolean values or expression. The OR operator evaluates an expression to false if both the Boolean values are false. It is true in all other cases. A truth table shows every possible result of a logical operator. The truth table for the OR operator. Expression, result. True or true, result is true. True or false, result is true. False or true, result is true. False or false, result is false. The truth table for the OR operator shows that an expression is false if both the Boolean values are false. It is true in all other cases. The logical operator OR is used when we want to test more than one condition. An example is A is greater than B or A is greater than C. This logical expression is false only if A is greater than B is false and A is greater than C is false. If either or both of them are true, the expression is true. Example: open Python IDE or any text editor, type this Python code and run it. In this Python code, 5 is assigned to A, 9 is assigned to B, 3 is assigned to C. Print A is greater than B or A is greater than C. The output will be true. Here A is greater than B, 5 is greater than 9 is false, but the second half of the expression, that is A is greater than C, 5 is greater than 3, is true. Hence the expression false or true is evaluated as true. According to the truth table, if either or both of them are true, the result is true. An expression is false if both the Boolean values are false. The NOT operator. The NOT operator is a unary operator. The NOT operator operates on only one Boolean value or expression. The NOT operator simply evaluates to the opposite Boolean value. That is, it changes a true value to false and a false value to true. The truth table for the NOT operator. Expression, result. Not true, result is false. Not false, result is true. The truth table for NOT operator shows that it changes a true value to false and a false value to true. Example: open the Python IDE or any text editor, type this Python code and run it. 9 is assigned to A. Print not A is greater than 4. The output will be false. In this Python code, the comparison operator is evaluated first. That is, A is greater than 4, 9 is greater than 4 is true. Then the logical operator not is evaluated. That is, not true is false. So the result is false. The NOT operator changes a true value to false and a false value to true. The NOT operator is used to reverse the result. We can nest NOT operators. For example, print not true will produce the output true. The first not true is evaluated. The result is false. Then not false is evaluated, which is true. Then the not true is evaluated, which is false. Finally, not false is evaluated, so the final result is true. How are logical expressions evaluated? Logical operators in Python, like math operators, have an order of operations. Python evaluates the NOT operators first, then the AND operators, and finally the OR operators after all math and comparison operators have been evaluated. The computer will evaluate the logical expressions from left to right. When it has the Boolean value for each expression, it will then evaluate the entire expression down to one Boolean value. For example, the evaluation process for 2 is less than 4 and 4 is less than 5 on the computer is as follows. The logical expression is evaluated from left to right. Python evaluates logical operators after all math and comparison operators have been evaluated. So, 2 is less than 4 is evaluated first, which is true. Then 4 is less than 5 is evaluated, which is true. Now logical operator AND is evaluated, that is true and true, the result is true. Short circuit evaluation of logical expressions in Python. When evaluating binary logical relationships, computer languages can use two methods. In the first method, the entire expression must be evaluated before the result is determined. This means that the AND expression must be evaluated completely even if the first operand is false and the result is known to be false. The second method immediately sets the result value once it is known. It is not required to evaluate the entire expression. In other words, it operates in a short circuit method, stopping the evaluation once it is certain of the final result. According to the short circuit approach, if the first operand of a logical AND expression is false, the second half of the expression is not evaluated because the result must be false. In the case of an OR expression, if the first operand is true, there is no need to evaluate the entire expression, so the resulting value is set to true immediately. Python uses this short circuit method. False and anything is false. True or anything is true. Example: open the Python IDE or any text editor, type this Python code and run it. In this Python code, 4 is assigned to A, 0 is assigned to B. Print A is greater than 5 and A by B is greater than 3. The output will be false. In this example, the first part of the AND expression A is greater than 5 is evaluated as false. So the second part of the expression A by B is greater than 3 is not evaluated because Python uses the short circuit technique for the evaluation of logical expressions. It stops the evaluation when it knows for sure what the final result will be. Here the result is false. If we change the assigned value of A to 6, then the first part of the AND expression is true. So then the second half of the expression will be evaluated, which gives us runtime errors because of division by 0. So in this way the short circuit method works. We can also use multiple logical operators in an expression along with comparison operators and arithmetic operators. For example, print 2 multiplied by 2 is equal to 2 plus 2 and not 3 plus 3 is equal to 5 and 4 multiplied by 2 is equal to 8. The output will be true. The evaluation process for 2 multiplied by 2 is equal to 2 plus 2 and not 3 plus 3 is equal to 5 and 4 multiplied by 2 is equal to 8 on the computer as follows. This expression contains arithmetic operators, comparison operators and logical operators. Python operators like math operators have an order of operations. Python evaluates all arithmetic operators first according to their order of precedence. For example, multiplication, division and modulo division operators have higher precedence than addition and subtraction. So the expression 2 multiplied by 2 is equal to 2 plus 2 and not 3 plus 3 is equal to 5 and 4 multiplied by 2 is equal to 8 will be evaluated to 4 is equal to 4 and not 6 is equal to 5 and 8 is equal to 8. Next, comparison operators are evaluated. So the expression 4 is equal to 4 and not 6 is equal to 5 and 8 is equal to 8 will be evaluated to true and not false and true. Then logical operators are evaluated. Python evaluates the logical operators not first, then AND operators and finally the OR operators. So the expression true and not false and true will be evaluated to true, not false will be true and true. Then the AND operators are evaluated. So the expression true and true and true will be evaluated to true and true. And then it will be evaluated to one Boolean value, that is true and true, result is true. Assignment operator. Assignment operators are used to assign the result of an expression to a variable. The assignment operator is the single equal sign. The general form is variable assignment operator expression. The left operand is an assignment operator must be a variable, not a literal. For example, 4 is assigned to A is correct form. A is assigned to 4, wrong. B plus 2 is assigned to A, correct. A is assigned to B plus 2, wrong. We can assign 4 to A where A is a variable, but we cannot assign the variable A to the value 4. Similarly, B plus 2 can be assigned to variable A, but A, which is a variable, cannot be assigned to the expression B plus 2, which is a literal. If the left operand in an assignment operator is not a variable, then we get a compilation error. There are two forms of assignment: simple assignment, augmented assignment. Simple assignment. The simple assignment operator uses a single equal sign to assign the value to a variable. Example: open the Python IDE or any text editor, type this Python code and run it. 4 is assigned to A is assigned to I, A plus 9 is assigned to B, print B. The output will be 13. The value of A is 4. 4 plus 9 is equal to 13. 13 is assigned to B, so the output will be 13. I plus 1 is assigned to I, print I. The output will be 5. The value of I is 4. 1 is added to 4. The result 5 is assigned to I, so the new value of I is 5. Assign the same value to multiple variables. Python allows us to assign the same value to multiple variables in one line. This is known as a chain of assignment. Example: open the Python IDE or any text editor, type this Python code and run it. 9 is assigned to A, B and C, that is same value to multiple variables. Print A, print B, print C. The output will be 9, 9 and 9. This Python code sets the variable A, B and C to 9 using a single statement. Python assigns values from right to left. So in this code 9 is assigned to C, which is then assigned to B, which in turn is assigned to A. Using a chain of assignment is an easy way to set a group of variables to a common value. Assign multiple values to multiple variables. Python allows us to assign multiple values to multiple variables in one line. This is known as parallel assignment. Example: open the Python IDE or any text editor, type this Python code and run it. 4, 9 and 27 are assigned to A, B and C. Print A, the output will be 4. Print B, the output will be 9. Print C, the output will be 27. 2.5, 9 and hello is assigned to X, Y and Z. Print X, print Y, print Z. The output will be 2.5, 9 and hello. Python assigns values from right to left. When we assign multiple variables in a single line, variable names are separated by comma. The variable names are declared to the left of the assignment operator. Similarly, the respective values of the variables are provided on the right hand side of the assignment operator separated by comma. In this code, A, B, C, X, Y and Z are variables declared to the left of the assignment operator and separated by comma. Similarly, 4, 9, 27, 2.5, 9 and hello are respective values of the variables that are provided on the right hand side of the assignment operator separated by comma. Augmented assignment operators. Arithmetic operators or bitwise operators can be combined with assignment operator to form augmented assignment operators. Augmented assignment operator is also known as compound assignment operator or shorthand assignment operator. The format of augmented assignment operator is V, OP, assignment operator, expression, where V is a variable, and OP is a Python binary arithmetic operator or bitwise operator. For example, a simple statement like a plus 9 is assigned to a can be rewritten in the form of augmented assignment statement as a plus augmented assignment operator 9. Here plus and equal sign is an augmented assignment operator. Another example, a modular division 4 is assigned to a can be expressed in augmented form as a modular division augmented assignment operator 4. In this case, modulo division and equal sign is an augmented assignment operator. Thus, any statement of the form V equal sign V OP expression can be rewritten in the form of as V OP equal sign expression. There are augmented assignment operators for all of the binary arithmetic operators and bitwise operators. Table: statement with augmented assignment operator, equivalent statement with simple assignment operator. A plus equal sign 1, which is in augmented form, can be written in simple assignment form as A equal sign A plus 1. Similarly, A minus equal sign 1 can be written as A equal sign A minus 1. A multiplication equal sign 1 can be written as A equal sign A multiplied by 1. A division equal sign 2 can be written as A equal sign A division by 2. A modulo division equal sign 2 can be written as A equal sign A modulo division 2. A floor division equal sign 3 can be written as A equal sign A floor division 3. A exponent equal sign 2 can be written as A equal sign A exponent 2. Example: open the Python IDE or any text editor, type this Python code and run it. 1 is assigned to A, 2 is assigned to B, 3 is assigned to C. A plus equal sign 4, B multiplication equal sign 5, C modulo division equal sign 2. Print A, the output will be 5. A plus equal sign 4 means A equal sign A plus 4. Here 4 is added to the value of A, 1, and then the result is assigned to A. So the new value of A is 5. 1 plus 4, that is 5. Print B, the output will be 10. B multiplication equal sign 5 means B equal sign B multiplication 5. Here the value of B, 2, is multiplied by 5 and then the result is assigned to B. So the new value of B is 10. 2 multiplied by 5, that is 10. Print C, the output will be 1. C modulo division equal sign 2 means the value of C, 3, is divided by 2 and the remainder 1 is assigned to C. So the new value of C is 1. C plus equal sign A multiplication B. Print C, the output will be 51. C plus equal sign A multiplication B means C equal sign C plus A multiplied by B. In this statement, the value of A will be multiplied by B first. In this statement, the value of A will be multiplied by B first. Then the result will be added to the value of C. Then the final result will be assigned to C. The new value of A is 5, which will be multiplied by the new value of B, which is 10. After multiplication, the intermediate result is 50, that is 5 multiplied by 10. Then 50 is added to the new value of the C, which is 1. So the final result is 51. The augmented assignment operator is performed last after all the operators in the statement are evaluated. In Python, there are augmented assignment operators for all of the binary arithmetic operators and bitwise operators. Arithmetic augmented assignment operators are plus, minus, multiplication, division, floor division, modulo division and exponent. Bitwise augmented assignment operators are bitwise and, bitwise or, left shift, right shift and bitwise XOR. What are the benefits of augmented assignment operators? The benefit of the augmented assignment operators is that they save a bit of typing because they are shorthand for their equivalent long forms. In some cases, they are more efficient than their equivalent long forms. Bitwise operators. Bitwise operators are used for the manipulation of data at the bit level. Bitwise operators are used for comparing the bits, inverting the bits, or shifting bits right or left. Bitwise operators may only be applied to integer operands. In bitwise operations, the integers are converted into binary form first, and then bitwise operations are performed at the bit level. It returns the result in the decimal number format. Python provides 6 bitwise operators for bit manipulations. The bitwise operators are summarized in the following table. Operator, meaning, description, bitwise not, invert all of the bits of its operand, that is, it reverses the bit value 0 to 1 and 1 to 0. Bitwise not is also known as one's complement operator. Bitwise and, the result is 1 only when both the bits are 1, otherwise it is 0. Bitwise or, the result is 0 when both the bits are 0, otherwise it is 1. Bitwise exclusive or XOR, the result is 1 only if one of the bit is 1 and other is 0. It is 0 if both operands bits are 1 or 0. That is, if both the bits are same, the result is 0. Left shift, it shifts all of the bits in a value to the left a specified number of times. The first operand is the value to be shifted. The second operand specifies the number of bits to be shifted. Right shift, it shifts all of the bits in a value to the right a specified number of times. The first operand is the value to be shifted. The second operand specifies the number of bits to be shifted. Bitwise not is an unary operator. All the others are binary operators. More about bitwise operators will be discussed later. Giving detailed descriptions and examples is not feasible right here at the moment. Identity operators. Identity operators are used to compare the memory locations of two objects. Python provides two identity operators, is operator and is not operator. Identity operators are binary operators. Is operator. The is operator compares two variables on either side of the operator. The result is true if both the variables point to the same memory location. It is false otherwise. Is not operator. The is not operator compares two variables on either side of the operator. The result is false if both the variables point to the same memory location. It is true otherwise. Membership operators. Membership operators are used to test if a value or a variable is or is not in a sequence. A sequence may be a string, a list, an array, or a tuple, etc. Membership operators return a Boolean value that is true or false. Membership operators are binary operator. Python provides two membership operators, in operator and not in operator. In operator. The in operator returns true if a value or a variable is found in the sequence. It is false otherwise. In not operator. The in not operator returns true if a value or a variable is not found in the sequence. It is false otherwise. More about identity operators and membership operators will be discussed later. Giving detailed descriptions and examples is not feasible right here at the moment. Thanks for watching. Please like, share and subscribe to our channel. Previous video was literals in Python. Next video is punctuator in Python. Contact us ambikarai27@gmail.com. Thank you.